Okay. All right.
Awesome. Great. So welcome everyone to our joint meeting between the VAST seminars and the SciCodes group. We are happy to have 4 speakers lined up today that are going to talk to us about all aspects of software publishing, citation, and discoverability. And we have a lot of time for open questions. And so we are going to strongly encourage everyone in the audience to be active with questions. And to do that, just open up the chat window, drop your questions in. After our brief talks from each of our participants, we will start going through all the questions. This is recorded, so if you don't want to be seen on the recording, just turn off your video, because if you talk, you're going to show up maybe on the recording. With that, just 2 more announcements. Next month, our plan for the seminars is grad student lightning talks. We are still looking for students to present any software they might have developed over the past year in their courses. Just a quick 5-minute lightning talk. Raise an issue or reach out to one of us if you want to do that. And in July, we're going to talk about teaching computational astronomy, teaching software to students. All right, so with that, we're going to get started. And our first speaker is Simon Hettrick. And Simon is at the Software Sustainability Institute. And Simon is going to talk about, in general, why publish software. So you should be able to go ahead and share.
Right, I shall share my screen.
Yep.
And hopefully you can see that okay.
Yep, looks great.
That's great. Okay, so yeah, so Michael was saying we're going to talk about citation, publishing, discoverability, and I've actually chosen to talk about none of those things. I'm talking instead about research culture and research incentives, because those are the things that underpin what we choose to cite, publish, and discover. So I'm with the Software Sustainability Institute. In fact, I'm a founding member. I've been there since 2010. And I've worked with a lot of different areas of research software. We were the first organization set up in the world to just really care about what happens with research software. If you've seen me talk before, then you'll have seen this slide. Charts back to 2014. It was the first ever study that we conducted of software reliance in research. And basically, we came to the conclusion around about 70% of researchers from all different backgrounds said that software was fundamental to the generation of results. This was the first time we'd made this sort of link between just quite how near ubiquitous software was across all research disciplines. And we've used it for lots of different purposes, for getting better policy in place, for getting more funding in place, for getting careers in place for research software engineers and other things like that. But today I'm using it to try and make the point that if research is a process and you're not talking about one of the fundamental building blocks of generating those results, then whatever it is you're doing, you're not conducting research. Research has to be open, it has to be reproducible if we expect to be able to build on that research. So on that front, we want to see culture change. And that's why I want to talk about incentives, because ultimately, if we want to change academic culture, then we need to change academic incentives, because culture will just follow what we choose to incentivize. And there are lots of different ways I can talk about the incentives we put in place, but because I'm based in the UK, I want to talk about the REF, because it's such a clear example. So you probably haven't heard of the REF. It's very important here. The Research Excellence Framework is conducted every 7 years by all research universities within the UK. And basically what they have to do is summarize the impact they've had in research. And on the back of that, billions of pounds of research funding is divided up, dependent on the score you get. So as you can imagine, universities treat it very, very seriously. They really care about the REF. As a framework, and we all love to talk about frameworks, I'm sure, it's a really good framework. It's a good background. There are 22 different categories in which of research outputs you can submit, and it spans everything from musical compositions right through to the thing I care about, software. The problem is this is the framework as it's handed to the universities, and it's people within the universities that interpret it and then put those submissions together. When you look at the results that come out of the REF, you might, with a keen eye, be able to notice a slight skew in the data. and that is that almost everything goes into publications. So we're talking about only in the last ref, which was run in 2021, only 2.4% of publications went into categories that, of research outputs went into categories that weren't related to publications. And why is that a problem, in my opinion? For two reasons. First of all, publications rarely talk about all of the aspects of the work that are necessary to reproduce the results, and that's especially the case with software. I know we're making a lot of progress with various different journals, but we're still not there. It's certainly not ubiquitous across all publications. And the other problem I have with it is that publications focus only on naming a few of the people who are involved in the generation of that research. Large numbers of people who we call vital but unrecognized roles in research, and that spans everybody from librarians to technicians to research software engineers. They're not referenced in the publication, and that means that they're not being supported. The skew in this data is so significant that one of my hobbies at the moment is trying to visualize it in a way that people will see. So like I've coming up with various different ideas as we're working through as I've been working through it. But I guess the point I want to get across here to really put into context for us and as people who care about software is in the last ref, 186,000 research outputs were submitted, and into the category for software, there were 11. And this is when we know that 70% of research is fundamentally reliant on software. It's obviously wrong. We are doing things to change it. So we're running a campaign called Hidden Ref, which focuses only on non-publication-based research outputs and looks to support all of those vital but unrecognized roles. And if you're in the UK in September, I suggest you come along to our festival because it'll be a really excellent affair. And to finish, about a minute longer than I was told to talk for, I just want to summarize that the reason that we're doing this and the reason I care about research culture and research incentives is that if we don't recognize the work that is vital to research, then I think we limit our ability to conduct research. And with that, I'll say thank you.
Awesome. Thank you, Simon. Just a note for all the audience, we will take questions in the chat. We're going to go through our 4 speakers, and then we'll take questions as a whole, and this will give us the opportunity for any of the speakers to address the questions in common. So I'm going to move on to our next speaker, Lauren Cadwallader. She's at PLOS, Public Library of Science, and her prompt, what she was asked to sort of address, is how journals integrate software into their publishing workflows. So Lauren, you can go ahead and share.
Thank you. All right, hopefully you can see my slides.
Yeah,
I think it's great to follow on from Simon, actually, because PLOS, the publisher I work for, have a kind of, I think, a very similar kind of attitude towards research, in that we are an open science kind of based publisher. We're non-profit, so really our whole mission is around making research more accountable, more transparent, and opening up that whole research process, like Simon was saying. So making sure that things like software and data are all recognized as fundamental to that research process. So I think this is it's nice to be here and talking about what publishers can do. And I guess it's important to note that not all publishers do this, but we certainly try and have a strong focus on open science. And my role is really to think about and to help push forward the adoption of data sharing and code sharing of publications. We publish, just a little bit of background on PLOS, if you don't know us, we publish 12 different journals. They're primarily in the health, life and environmental sciences, but we do publish PLOS One. It's one of the largest journals in the world. It publishes research on any topic, as long as it's of high quality and a rigorous standard. So there's always a home for your research there. One of the things that we try and do is make sure that we have really clear policies and guidance around all of those kind of extra outputs around the publications that should be shared. So we've had a mandatory data sharing policy since 2014. It was quite revolutionary when it came in. And we also have policies around sharing software and materials and code. One thing I wanted to note is that this is our kind of policy as in PLOS 1, and we have pages on materials, software and code sharing, but you also see here there's a related policy on data availability. Just to note that some publishers use data as a really big umbrella term, and that they will put software sharing underneath data, right? So it can be quite a confusing landscape when you're kind of picking a journal and trying to work out what you need to share and where you need to share it. But we try and separate those out because we want to recognize them as important elements within their own right. And so just to kind of note on software and code, right, because I talked to a lot of different disciplines and they use the terms in a lot of different kind of interchangeable ways. But generally for software, we're thinking about this kind of software submission, this standalone bit of work that essentially is the article in itself. In this case, sharing is mandatory for that piece of software. Whereas when we talk about code sharing, we're thinking more about those kind of more traditional research articles where code is kind of underpinning the analysis. It's not necessarily central, it's your article is kind of talking about something else and code's just kind of supporting the way that you got to those results. And there sharing is encouraged unless you're publishing in our journal PLOS Computational Biology, in which case it's mandatory. I just wanted to kind of cover a few things we require with software submissions, and to give you an idea of the kind of things journals could ask you to do. And so we have a lot of mandatory requirements around that, various things that you must do if you're submitting a software submission. And that's really, these are really geared around to try and make that piece of software as openly available as possible, as reusable as possible, and for that longer, kind of into the long term as well. So we expect that that software remains available and usable and is maintained. So things like we require that it's based on open source kind of standards and definitions, it's in an open source archive, and we give examples of ones that you can use, that it's properly linked out from this article, and that software submission itself is well documented. Everything that you describe in the article is there in itself, including any test data that might be useful. So we're really trying to make sure that researchers are kind of maximizing that usability of that software, and actually it's there and it's useful for other people into the future. And just one point to add that a lot of other publishers have kind of similar guidelines. They might not necessarily be required and only strongly encouraged, but other publishers actually have copied our guidelines because we've written them so well. Then just a quick point on software citation, because I was asked about that as well. We encourage it at all our journals, and we were part of the Force 11 working group that set about kind of writing the guidelines around software citation. And this is just a screenshot from the Chorus webpage, which is trying to list all the publishers that have software citation policies and where you can find those policies. It's not an exhaustive list, it's an opt-in list. But there are central resources around what publishers require and what they do. And then just one last point, we do a lot of research at PLOS. I've been doing a lot of research on code sharing, so more of that kind of code that's underpinning a publication rather than software. And if you're interested in that, we do make all our research available in line with our open principles. So our data sets are available and our articles are preprint. And if anyone's interested in that, I'm happy to talk about it more afterwards. But I will leave it there, and hopefully it wasn't too far over 4 minutes.
Awesome. Yeah, no, I think you're great. Thank you for sharing that. Just a reminder to everyone, drop questions in the chat after we get through the next two presentations. We're going to take general questions, and we'll be happy to answer everything there. Thank you, Lauren. Next up, we have Edwin Henneken from the NASA ADS service, and you were asked to talk about how do indexing systems work.
Yeah, thank you. Yeah, so I've been with ADS for about 20 years. I'm currently the content curation and collaborations lead of the team. And so we're mostly known for indexing literature, but we also try to track software citations. Currently, we have about 17 million records in our system and 167 million citations. Discovery of software products through the ADS essentially means discovery of software as it is used in the scientific literature. And let's see. Yeah, this is. So that means that the ADS captures software use via formal citations. And these come in various forms, as is illustrated on this slide. For example, people cite one of many software-centric journals, or they cite a Zenodo software record or an ASCL record. So the way the ADS counts citations, and that is important to stress, it means that both the citing and the cited work must be indexed in our system. And there are basically two ways to make this happen. So the two ways to capturing software citations in ADS are pretty straightforward. The first one is the cited work is already indexed, and the citation is then assigned automatically, which means that it's, for example, a software journal that we're indexing automatically, or in the case of ASCL, Alice sends us updates of the ASCL records, which then automatically get indexed. But the other way is basically was initiative together with the AAS meeting in a project called Asclepius, where we basically detect software citations through DOIs associated with the software. And then we pull metadata from DataCite and create a record in our system, and then we assign the citation. The table on this slide gives just a snapshot of a couple of software presentations in our system. Like currently we have just over 15,000 records for Zenodo software records, which currently have accrued about 30,000 citations, and about 3,000 ACL records with about 11,000 citations, and astronomy and computing and JOS and SoftX are some other software representation in our system. So having these citations available in ADS greatly improves the visibility of software and provides insight into the context in which software is used, because you immediately see the literature in which the software was cited, and the ADS allows you to explore the context basically, and also you're able to provide impact measures for software, because one of our services is a citation metrics report, and that's all I have.
Great, thank you. All right, so after Edwin, our last speaker for now is Alice Allen, our own Alice Allen, from the Astronomy Software. Oh, geez, what's a C? Brain freeze here. Oh, you're on mute, Alice. ASCL. She'll tell us what the C is. Stay tuned.
Yes.
And Alice is going to talk to us about how do registries and repositories enable software discovery. Sorry.
Okay.
Oh, source code. Yeah.
Thank you. And I'm assuming you can see my slide, right?
I can.
Okay, great. Thanks. Okay, so the C is for code, Astrophysics source code library. And I'm going to talk from the perspective of the ASCL, but about registries in general. And I need to click here to advance the slide. Okay, so for this presentation, I'm using the word registries to cover two basic types of resources: repositories, which require that software be deposited with them, and registries, which hold information about software, including usually where to find the software. Because most repositories also include at least some metadata about software, the term registries fits both services, and that's usually what I use. But both of these are good places to find software. So many places to put software and information about software exist. They have different goals and different structures. We might group them loosely into these categories. There are national efforts, such as the Australia Research Data Commons, HAL in France, and the Research Software Directory in the Netherlands. There are organizational efforts, including university registries and repositories run by funders, such as the US Department of Energy. There are also general ones that are generally open to the public, and these would include Software Heritage and Zenodo. And then there are discipline-specific registries that include the computational infrastructure for geodynamics, BioTools, which serves the bioinformatics and life sciences disciplines, and the Astrophysics source code library. So we can say that though there are all kinds of different repositories and registries, they're all places to discover software, to look for software. I'll share some of the ways the ASCL's metadata is used in our discipline that increases discoverability. These are the ASCL's examples, but other registries do many of these things as well. We collect information about software and provide a site that people can search to find software, but other good things come out of our collection. Collecting this information creates new opportunities. Just as journal papers can be indexed by, for example, Web of Science, the ASCL's collection of information can be and is ingested by indexing services. So, for example, our metadata appears in Web of Science and on Google Scholar, and most importantly for the Astro community, in Astro's main indexer, the NASA's Astrophysics Data System, or ADS, which Edwin discussed. So in addition, we, as do other registries, assign a unique identifier to our entries, and this makes our software entries citable. ADS does an excellent job of tracking citations to ASCL entries. Here you can see that the ASCL entry for the Dolphote software has been cited 101 times. Actually, as of today, it's 104, but I didn't update the slide. But that's not all. ADS can also use ASCL metadata to link Dolphote, for example, to a research paper that uses this software and to a journal article that describes the software. And the converse is also true. ADS links this stellar photometry paper to the Dolphote software. Again, this is based on metadata that ADS harvests from the ASCL and provides more opportunities for software to be discovered. Citing software provides greater exposure for that software. There are many other registries do these or similar things, and like the ASCL, improve the discoverability and increase the visibility of the software in their collections. To increase the visibility and discoverability of your own code, it's not enough to just have it on GitHub. Deposit it in a registry or multiple registries and make it truly citable. And I would encourage you, regardless of what discipline you're in, to find your discipline-specific registry and deposit your software there. And that's all. I hope that came in under 4 minutes.
Yes, I think we're great on time. Thank you, Alice, and thank you everyone for your presentations. At this point, we're going to transition to questions. Remember, you can drop questions in the chat, or you can raise your hand virtually. I think in participants, there's an icon for that. I'm going to turn things over to Tom from SciCodes, who's going to handle the questions part. And I can't find him on my screen, but
thank you so much.
There we go.
So I'm going to start off with the questions that came in on the chat during the presentations. So for Simon, we had a question from Amruta. Is there also a bias such that software associated with a particular project is reported and cited, but the ones that are used by the community aren't?
Well, I have no evidence to show that, but I can bet that is the case. So I think when we've had a look at things like, there's other ways of collecting research outputs in the UK, and one of them is called ResearchFish, and I did a study based on that once. And we found that what came down to what really drove software being registered as an output was the culture within that project. So some projects producing tons of software didn't register any of it as an output. Other ones had a culture of thinking software is important, and they were like, they were registering a lot of their software. And I think the same thing happens when you look at the software you're generating within a project, which you see has been very close to you, and you think about that's the stuff you're going to put out as a research output, and the millions of libraries and other people's code that you rely on to conduct your work, you overlook when it comes to registering them. So yeah, I think that would absolutely be the case. I'd love to look into it.
Thank you so much. For Lauren, are there plans for PLOS to expand more into physical sciences or other non-biology fields?
Yes, there are, but I can't really say too much about it, other than hopefully next month I can say some more about it. But yeah, we're expanding our kind of our journal portfolio, and when our new titles are announced, I can definitely let Alice and Michael know to send out to the wider list.
Very exciting. And how does PLOS deal with software available upon request in papers?
So if it's a software paper, we don't allow it, right? So software has to be openly available. Where there's a mandatory code policy, again, like that has to be openly available, unless there's something like a really good legal ethical restriction that says it can't be available, and then there are other ways to access it, and that that is not contact the authors, that has to be contact this ethics committee or this committee to get access, and through like a kind of managed access portal, then that's okay. What we do recognize, I guess, however, is that communities have different norms about how they use software, or what different kind of dependencies there might be. And so whilst we really strongly encourage and want everything to be open source, if there is a community that uses proprietary software like MATLAB, and that is very common within the community, then we will allow those kind of exceptions, that something that has a dependency on MATLAB could be published. But it has to be something that's really common and really strongly and well accepted in the community.
Awesome, thanks. So we've got one question that I think is for probably both Alice and Edwin, but if other panelists want to chime in, feel free to as well. So as a registry publisher, if you're storing data about a software's authors, what's the infrastructure behind this? Do you use identifiers like ORCID, or do you rely on author names? And also from an EDI perspective, how do you deal with author name changes? And this is from Jost.
Well,
Okay. Edwin, your response is going to be more robust. I'm going to say we do not use ORCID, and there are numerous reasons for that. The overhead on that and getting that information from us to ADS and back is too onerous for a volunteer-run organization like the ASCL, and that's unfortunate. But I know ADS does a really good job of this, and Edwin will tell you about that, I'm sure.
Yeah, we basically use all of the above. It all depends on how rich the metadata is that we are provided. Like if it is a software journal, if the metadata contains ORCIDs, we index those ORCIDs together with author names and affiliations. With Zenodo software records, one challenge can be that people not always include their actual names, but just their GitHub handles. So I would say, if as a software author, if you really care about that your name appears properly, like in an ADS record, then make sure that it ends up in like the metadata that gets registered in DataCite. And with name changes, well, at least in astronomy, we have a very active users group who, whenever their name changes, they know that they can contact us, and we do all the curation that is necessary to update the names in our system and link them through like author synonyms. That if you do a query for like the old version of your name, that the system knows about the later versions too. And the ADS also allows for publication claiming to add the publications to your ORCID profile. So those are pretty much all the bells and whistles in our system. I hope that answered the question sufficiently.
That's awesome. Alice, does ADS support name changes from a policy perspective?
ADS has been great in handling.
Oh, sorry, ASCL. I'm mixing up my analogies.
Right, and we will change names upon request, of course. So, but ADS handles that really well. So when they get stuff, but if we don't know about the name change, we can't support it. So people should let us know about the name change. I think Simon has something to say on this.
Yeah.
Yeah, I was just going to add. So, as people who are involved in registries, are you seeing the rise of citation file usage? And is that making this job with names more easy to deal with, and names and identifiers more easy to deal with?
So we're currently not actively using those citation files. We're currently purely relying on metadata and DataCite, and the data that we get from the publishers, if it is like a software journal.
I know we have a number of registries online, and I don't want to so maybe other registries. I mean, I know what the ASCL does, but what astronomy is doing, but there are people who run other registries that might want to comment on that. Are you seeing greater use of, for example, CodeMeta.json or citation file format in your fields?
I will add from my perspective. We're starting to see a little bit of uptake, and there are some exciting developments around kind of general registry support for citation files like CodeMeta and citation.cff, including possible support, more additional support for Zenodo, which will be very exciting. So be on the lookout for new announcements about that in the upcoming months. We've got another question for Simon. So with respect to the Hidden Ref project, how do you deal with software papers? So Alex Wade says he presumes they count as publications, but then that does that mean that they don't actually highlight that that's a software thing as opposed to more of a paper thing?
Whenever you put together something where you're trying to make a stand, you always end up with these terrible crossover outputs or submissions, and they always cause you a bit of a headache. So there's a lot of them actually also there are like publications, especially in the humanities, that are largely overlooked, that we were asked to consider as well. And we had to kind of, because it's such a broad field and we can't be experts enough in all of these fields to understand where to set the bar, we just took a very hardline approach when no publications. So software papers themselves won't be submittable, but you can submit the software that paper is based on. That's more than allowable. I guess the thing I should say when it comes to things like running the Hidden Ref, this is it's a campaign to raise recognition about something that we're trying to get people talking and thinking about. So we're not putting together the most stringent assessment criteria. We're really running it just to get people thinking about these subjects and doing something about it. So we haven't spent a huge amount of time on working out which possible paper-looking things could be submittable or not. We've just kind of taken a blanket approach. We won't have anything that looks like a publication.
All right, I think this is probably for Lauren. So from Michael, we've got a question. Are there any ideas from journals to move beyond static PDFs for publication, especially for software publications, and allow interactive documents like Jupyter Notebooks to serve as the publication?
Yes. Yeah, this is a really interesting space, I think, right now in journals and publications. AGU had a big grant from, I think, the Sloan Foundation to run a project called Notebooks Now! And that whole project is designed to look around how to kind of create and facilitate the submission of like a Jupyter notebook, a notebook of some sort, as the output. So it's not an article with a notebook in support. It's you know, it's the notebook itself is the output. There are a number of kind of challenges for publishers around that, and a lot of it's infrastructure based in terms of the way that we kind of ingest submissions from researchers, and the way that that can then be displayed on a website, and you know, making sure that all fits in with, you know, the current systems you have and the ways you're working with. So there's kind of like a number of technical challenges that need addressing, and this group is looking at, and then there are, I guess, a number of challenges around trying to, I guess, streamline that process slightly for publishers, in terms of there's, you know, a great number of variations of ways that you could present that, or languages you could use. So it's also looking to come up with kind of templates and guidance to try and really steer researchers into like, I don't want to say the right direction, right? Because we shouldn't be dictating to communities about how to produce their research, right? But making sure that all the elements that are important are there, and that they are presented in the right way that makes rendering on at the website at the endpoint usable and feasible, and, you know, and that it works through a kind of peer review process as well. Oh, I'll try and find a web link and put it in the chat project.
Great, thanks.
Alice, do you have another comment on the Jupyter Notebook question?
I'm just saying that ASCL accepts Jupyter Notebooks as submissions, and if I recall correctly, numerous other registries do as well. And if anybody representing those other registries wants to chime in, you know, please do, either on chat or by raising your hand. So, but I do see more and more of those types of interactive coding platforms, I guess we could call them, showing up.
I've got a question here from Amruta, which I think is for the whole panel. So what do people have? What are people's thoughts about connecting software updates and depreciation through citations? Or how to kind of connect kind of new updates and new software? How do you kind of cross-link between different types of software?
Well, we don't do anything about deprecation when software is deprecated, except we may list a new entry for software that has been significantly changed from a previous version. We do encourage people to cite software using the version number to ensure that people know which version of the software was used in the research. I know that's something that ADS supports as well, and and so do the other so do citation formats such as CodeMeta and CodeMeta.json and citation.cff. And we do cross-reference when we create a new entry for a particular software package, because it's been significantly updated. We do cross-reference that, and ADS picks up those cross-references as well, because they're in the abstract of the software. I don't know what others might be doing, but if they want to say something, like I know Alex from Zenodo is on, he might want to. I know Zenodo has a robust way of managing different software versions, and he might want to say something about that. Am I putting you on the spot, Alex?
Yes. So yes, regarding the version, we do make sure, for example, that files across across versions are never duplicated. Right? We don't get the same DOI basically assigned to the same server file. all the time. Again, new versions, they get new UIs. They're all linked together, so you can see the history between the different software versions. But yeah, that's kind of what's fun.
Thanks, Alex. Simon, you got your hand up?
So we've kind of had this idea of trying to look at the lifetime of software that appears on GitHub, because it's just why we chose GitHub, because it's a good place to find lots of research software. And we've been kind of trying to identify the software that's related to research by picking up from papers, looking at those repositories, and then tracking the repositories to see how things change, looking at, the way that tickets are dealt with, the number of pushes being made, all these sort of various different factors. And the idea was to create this kind of ECG of software, so you could kind of look at it and you could work out where it was in its lifespan, how close to deprecation or worse it was. And it's been phenomenally difficult because people have such a varied way of interacting with GitHub. We are trying to kind of create some sort of groupings. So you get a lot of software where you see nothing at all, and then there's like one deposit into the repository, there's a publication very soon afterwards, and then nothing happens. And it's obviously like they've been put under pressure to put their software into GitHub in an open and accessible way, but then they're not interested in it afterwards. And then you see these massive community projects that have managed to get hundreds and hundreds of contributors, and they sort of have a hum of activity throughout. And those are the kind of edge cases. But trying to identify different cases between those two has just been incredibly difficult. We are working on it, but I don't really have much to share at the moment. And if anybody wants to work on a project like that, I would love to hear from them.
Awesome. And Edwin, you've got a comment on this?
Yeah, the ADS perspective that citations are always a bit of an indirect measure of how software is being used, and since we only, definitely in the case of like Zenodo software records, we index software as it has been cited. So we never have, or we rarely have a complete picture of all the available software versions of a particular piece of software. So yeah, you could look at the most recently cited version, but I think using ADS, it's probably pretty much impossible to get alerted of software being deprecated or any such measures.
And Lauren?
Yeah, I just wanted to, I guess, make an adjacent point. That we did some research asking, so I guess I'll start from when we ask people to share stuff, right? We want them to put it in a repository or registry, so there is an archived version that can't change, and that's important for reproducibility, right? So that people can use the actual software that was used in your research. But we did some research asking readers of articles, essentially, like, what do you want to do with the code and the software that's related to the paper you're reading? And and how do you want to access that? And it was a really interesting split, right? Most people want a link to a GitHub account because they want to go and see the latest version, right? They don't necessarily want the version that their article's written on. They want the one that's been debugged and has all the updates and is going to work better. So I think there's a really interesting kind of trade-off or kind of way to think about when you're citing kind of software, that there's both that record that you need for reproducibility, but there's also perhaps that more usable or useful version to future researchers, which is the updated or the one that's being continually worked on if it's still in progress. I mean, and I guess ideally you would cite both your GitHub and your Zenodo record or whatever registry you're using, right?
Alex, do you want to talk about citation.cif and Zenodo.json?
Yes, sorry, I missed my window before. So yeah, basically, I think after we introduced the integration, it's also preferable for us to let people follow a standard like a citation preferred rather than having to go through documentation to figure out what the .enable JSON file would accept as validated. So so people prefer it, and we push for it as well. As I said. Also, they can validate it easier. There's many tools and already kind of automations about keeping it up to date and validating it, or just having it part of your repository, and it just works. Versus the zonalization file. So yeah, that's a good. It's a better place.
Yeah, Amrita?
So as a follow-up to that question, sorry, I don't mean to monopolize the question time. Would it help to recognize keywords for identifying softwares, for example, based on techniques that people use, or keywords, based on the kind of analysis that someone would like to do, so that just looking through that keyword, people would be able to discover softwares and also use them, or softwares that are related to things that people are already using?
From the perspective of the ASCL, we would love to have more keywords. And the reason we don't already do that is because when I started working on the ASCL, we decided that full text search beats keywords. So Google beats Yahoo, right? So we stopped listing keywords. Now that maybe was not the best decision, and we kind of wish we had kept keywords. We do have a keywords field now. The problem is filling it. There in astronomy, there is a thesaurus that can be used, but it's pretty complex for quick access or quick determination of what should be included in ASCL keywords, for example. And we don't want to, we expose keyword fields only when we have information in them. And right now we just have funder information, such as NASA, specifically NASA, in the keyword field. But we would love to do that. I know that other fields are doing a much better job of that, of having keywords indicate the type of analysis. And I think that's something that other registries could speak to better than I can.
Edwin, I'm curious from the ADS perspective, do you see any, what do you do in terms of handling keywords? Are there vocabularies that you prefer to use or make sense for software?
Well, we love keywords, but preferably ones that come from a controlled dictionary, because different persons may use different phraseology, and then it kind of defeats the purpose of a keyword system. But yeah, Alice meant the Unified Astronomy Thesaurus. That's typical for astronomy. But yeah, if for other disciplines, for computer science, for physics, if there are controlled dictionaries that can be used to assign keywords, it only helps with the discoverability. So we're a big fan of keywords.
We got another question from Warwick. So by making software citable, do we risk introducing academic incentives that are perverse in the context of software? So could we be inadvertently encouraging researchers to rewrite their own software to get another citable first author object rather than collaborating on larger projects? And this is probably rooted deep in the wider academic fixation with first authorship. Anyone on the panel have thoughts on that one?
I would love it if people came to recognize first authorship on software as on par with publication. I mean, I kind of think that would be wonderful, but often software citation is not is not appreciated as much as publication citation, and that's still an uphill battle for science in general. It's not just in astronomy; it's everywhere. We'd like to see, the journal is one artifact of research, but so is the software, and so are the data. So getting those on an equal footing is still has not been done yet, as far as Simon's research clearly showed. Publications way outweigh other things. Yet the most cited things are typically not publications, but tools, computational methods. So if you look at the artifacts that have the most citations in different indexers, such as ADS, a lot of the most cited entities are software entities, not publications. So, I'd love it if people wanted to rewrite their software because they found the software, first authorship of software publication being really valuable, but I don't think we're there yet. So I'm not worried about that issue.
Simon?
So I know I'm working in the area of research incentives at the moment, fully in the knowledge that any incentive system we put into place that will be fairer at first will be manipulated until it's not fairer in certain areas. That's unfortunately the way that all incentive systems go. So I think what you're trying to do is trying to make them fairer and never completely fair. I could see definitely that, if you put a system in place where first author on a software repository was as important as first author on a paper, then people would start coming up with ways of getting around that. You'd start working with your collaborators, and you mention me on your repository and I'll mention you on yours. That happens a lot with publications. So I think it's just a case of trying to push the system in the right direction. What I worry sometimes about and we saw this with the RSE, the Research Software Engineer career, when we first started putting it in place. People said, but if you do that, doesn't that mean then people who are research software engineers will be within this career and they'll be sort of valued, and then anybody outside of that will not be valued, and you'll just be replicating the same problem that happened with the research career? And I thought, well, yes, that is possible, but at least we have another set of people who are being valued, and then we'll work on the next ones. So it's just an iterative process of trying to work out where the unfairnesses are in the system, solve them, and then see where the next unfairnesses in the system are and work on those.
And Lauren?
Yeah, I think I'll just add to that I think there's also a question around openness and quality of the output as well. It would be great to have software data, whatever protocols, whatever it is, on kind of equal footing with publications. And I don't think it's just about having them on equal footing, but also thinking about the quality of those outputs as well. And that's harder to measure. You can measure whether something's open or not, what kind of licenses it have, for example. But it would be nice to move towards a system where it looks at the quality of those outputs as well. So actually, is there enough documentation that software can be reused, or that data can be reused as well, rather than just kind of shoving something in a repository and pointing someone to a DOI to show that you're putting stuff out there when we want to make sure you're actually doing the best you can with those outputs.
We are rapidly coming up to the end of our session. So do we have any last questions for any of our panelists?
I have a question for participants, for attendees.
Go for
What
it,
would
Alice.
help? Yeah, what would help? What can publishers, software registries, indexers do to help you to improve recognition for the software that you write? If you have ideas, I'd love to know what they are, because we can maybe work on them. So what might help? What could we all do better? what could those of us who were on the panel do better or do differently or start to do or stop doing that would help you as software authors?
I think that's a great question, Alice. And, you know, there are various initiatives, and I'm on some of them and trying to lead some of them that bring, you know, publishers together. So try and make a more unified front from publishers when it comes to requirements around these things. So actually there is a mechanism for change or lobbying to kind of make your lives easier as researchers.
Well, hopefully people will feel free to contact us, you know, to say, do this, or maybe let's try that. So please do, because I'm always interested to know what we could be doing better or what would help. So.
I have to say that I think that sort of community-based approach to research is the way forward. It's, you know, you don't have to rely on just the people who are working in your local group, but everybody in an international community can chip in ideas, provide their help. It's absolutely the most powerful way of doing research in the modern world.
And that's one of the reasons for having SciCodes, which is this consortium of software registries and repositories. We want to try to improve our own resources, but also work together collaboratively for change within science overall, not just our own disciplines, but change that is meaningful across disciplines. So. And as Frank says, it's a marathon, not a sprint. So.
I think an interesting question is where do you want it to be by the time that your research career is over? And that, I think, will be an interesting thing. So I'm kind of trying to work out what I want to have changed by the time I come to retirement, and what problems I leave behind for the next generation.
Yeah.
Well, folks, I think we're at noon. Well, noon for those of us on the East Coast. So thank you everyone for joining. Thank you our 4 speakers / panelists. Thank you, Tom, for handling questions. And thank you everyone for the great questions. We have recorded this. It'll be posted in the next few weeks or so on our website. We should also, I also dropped the link for the SciCodes. And so you should check out what SciCodes does, and we thank them for jointly hosting with us today. We're always looking for more speakers. Go to our project website, raise a GitHub issue if you want to become a speaker. Tell everyone about your fun codes that you've been working on. And I think that's it for today.
And if you're mentoring any graduate students writing code, please have them submit for next month.
All right, folks.